This is section 2.4, cross product. So whereas the dot product yields a number, a scalar, the cross product is going to give us a vector. Now, before I can define the cross product, I need to explain what the determinant of this matrix is. So if I have A, B, C, D, four numbers with straight bars around them, that means determinant, and we multiply on the main diagonal and then subtract the product on the off diagonal. So for example, this determinant here is 2 times 2, which is 4, minus -3, which is 7. Okay, now we're ready to cross two vectors in R3. So cross is not defined in R2, only in R3. So if you have two vectors, u and v, the determinant is, the cross product is the determinant of a special matrix, and so here's how you're going to compute it. Now, you're not going to memorize the formula. You're going to memorize the process. So this looks pretty darn busy, but actually it's pretty straightforward once you do a few of them. So first thing you're going to do is write down I, j, and k on the top row, and then put your u's on the middle row and your v's on the last row, and you need straight bars. And I definitely need to see this step here. Okay, straight bars, and then u and v. Then to compute the cross product in terms of what we have above, you are going to cross out top row, first column, and take the determinant of the four numbers that are left. And then for the middle entry is always negative, so there's an extra negative sign. And then cross out top row, middle column. So first, cross out first column, middle, cross out middle column. Take the determinant of the four numbers that are left. So these two and these two I put into the determinant sign. Finally, you guessed it, cross out the last column, first row, take the determinant of the four numbers that are left. And that will give you a vector. So remember, dot product yields a scalar, that's a number. Cross product yields a vector. So let's do some crossing. We want u cross v for these two vectors. And I'm going to show you what you actually have to show me and what you can do in your head once you get good at this if you want. So the first step, which I definitely have to see, is I, J, and K, and I definitely need to see those. A lot of students leave them off because they don't really come into the computation, but it's important. So 3, 0, 5, 2, -3, -2. Okay, now personally, when I'm doing this, I'm going to go straight from there to the answer, which is, I believe, 15, 16, -9. And pretty soon you'll be able to do that too. So I need to see this first step. Obviously, I need to see the answer. How to get that answer? So here's an optional step. You can actually write down your work. So this is a vector now. I'm going to cross out first row, first column, and take the determinant of 0, 5, -3, -2, comma. Second entry is always negative. I'm going to cross out second column, write down what's left. 3, 5, 2, -2, comma. Last guy, cross out last column there, and we get 3, 0, 2, -3. Now we compute those three numbers. So I want 0, so this is equal to 0 minus -15. That's how I got positive 15. Second entry is negative, and it's going to be -6 minus 10, which is -16. Negative is a positive. That's how I got positive 16. Last entry, -9 minus 0 is -9. So believe me, you'll be able to do this in your head eventually, but there's no harm in writing it down either. That way, if you make a mistake, you can go back and find out what your mistake was. All right, so why don't you pause it and do V cross U? All right, so hopefully you did the first step, IJK, correctly, and you need these straight bars. You wouldn't believe how many times I'll see on a test, I'll just see, U cross V, and people will leave out either the bars or the IJK, and I see things like, 305, 2, -3, -2. Maybe they'll put the IJK, but then no bars. So make sure your notation is correct. All right, now I'm going to put V in. The V in goes in the second row, 2, -3, -2, and U goes in the last row. So the only difference is we're changing the order. Okay, and so when you do this, you should have gotten the negative of this vector. So when I do the first entry, I get -15 minus 0, -15. Second entry, I get 10 plus 6 is 16, but second entry is negative, so -16. And then last entry, I get 0 minus a -9 is +9. So notice V cross U is negative U cross V. That's not a coincidence. It's always true. V cross V, IJK, V is 2, -3, -2. Put that again. All right, so we get +6 minus 6 is 0. Second entry is negative, but it's going to be -4 plus 4. -0 is still 0. Last entry is going to be 2 times -6 plus 6, again 0. So when you cross a vector with itself, you'll always get the 0 vector. So that's not a coincidence either. And then this last one, guess it's not a coincidence either. What happens when we take U cross V and we dot it with U? So U cross V is 15, 16, -9. And I'm going to dot it with U, which is, what's U? 305. So we get 45 plus 0 minus 45. Oh, I get 0. So that means U is perpendicular to U cross V, because when two vectors dot to 0, they're perpendicular. So keep that in mind for later. Okay, and then before I talk about properties, which is going to generalize these examples that we've seen, there's a quick way to cross the standard unit vectors. You make a circle, I, J, K, and you put arrows from I to J, J to K, K to I. When you cross two standard unit vectors, you follow the circle. So I cross J, so go this way, I cross J is K. J cross I. So if I want J cross I, I'm going against the arrows. If you go against the arrows, you still get the next letter in the circle, but it's negative. Negative K. And then finally, J cross K. So J cross K. Okay, let me erase. J cross K is I. All right. You can also get these answers by just doing the standard cross that we did up above. All right, some properties, and we're gonna state the property, and then if there's a similar property for dot, we're gonna state that too, just so we can tie this into what we learned last time. A constant scalar times U cross V is the same as, you can pull that scalar out, U cross V, or you can group the scalar with V. So the scalar can go completely out, or with the U, or with the V. Is there a similar property for dot? Yes, there is. C times U dot V is either CU dot V or it's U dot CV. It goes with one of the U or the V, not both. V cross U is negative U cross V. So this is called anti-commutative. If I change the order of u and v, I get negative u cross v. So anti-commutative, whereas dot is commutative. U dot v is the same as v dot u. All right, there's a distributive property. This is u cross v plus u cross w. We have a property, we have the same property for dot. This is u dot v plus u dot w. Okay, now it seems like I have the same property as 3, except written in different order. Now I'm crossing with u over here. And I need to state this as a separate property because cross is not commutative. Okay, so this is v, just keep the order straight, v cross u plus w cross u. Now, for dot, I didn't have a separate property for v plus w dotting with u on this side because it's not needed. Because dot is commutative. So that's why we had no separate property there. V cross v, we saw above, when we cross a vector with itself, we get the 0 vector. What's u dot u? Well, it's certainly not 0. U dot u is the length of u squared. All right, the 0 vector cross u is going to be the 0 vector. And we had a similar property for dot. If we take the 0 vector, dot it with u, we get 0 the scalar. So here it's 0 the scalar, here it's 0 the vector. The big surprise is that cross is not associative. So this is the first operation you've probably seen in your mathematical life that's not associative, meaning you can't just move the parentheses around. So I have what the associative property would be right here. I want to move those parentheses over to here. I can't do it. That's amazing. So that's why I'm so careful up here with using those parentheses, because it really does matter what operation you do first. And so here's an example where I take I cross j, and I don't get I cross j. So I just moved the parentheses and I got two different things, 0 versus negative j. Okay, so here's an example. Suppose u cross v is this vector. Find this big long vector here. So this is going to take a little while, so hang on. I'm going to go fast. You can always slow down the recording. Let's call this W. What I want is W cross u plus 2v. All right, now by properties above, distributive property, this is W cross u plus W cross 2v. All right, now I'm going to put back in what W is. W is u minus 3v. Okay, so I have u minus 3v, and I want to cross it with u. And I want to add on u minus 3v crossed with 2v. So what I'm doing here is really kind of a FOIL. Now I'm going to expand again. This is u cross u. All right, minus, put that in parentheses, 3v cross u. Plus u cross 2v. Yes, that 2 can come out, and we'll pull it out in a second. Minus 3v cross 2v is negative, so minus 6v cross v. Okay, u cross u is the 0 vector. V cross v is the 0 vector. So this is going to give us 0 over here. So this is 0. we want to write eventually, the only thing I know is what U cross V is. So I'm trying to write all of these in terms of U cross V. That's my goal. I should have stated that at the beginning. So V cross U is negative U cross V. So I can switch the order here as long as I make that a positive 3. All right, I can pull the 2 out here, U cross V, and then this is minus 0, 6 times 0, 0. And this is the 0 vector, and that's the 0 vector. Okay, so that's 5 U cross V. Finally, I'm done. That's 5. U cross V is 0, negative 1, 1. So I get 0, negative 5, 5. Okay, geometric properties of cross product. First, U cross V is orthogonal to U and it's orthogonal to V. That's great because we're always going to want to be finding a vector that's orthogonal to two other vectors. So what this means, if I state it mathematically, U cross V, if I dot it with U, I'm going to get 0. And if I dot it with V, I'm going to get 0. All right. Another big property, the length of U cross V is the area of the parallelogram spanned by U and V. So here's U, here's V. They span a parallelogram. The area of that parallelogram is the length of U cross V. Okay. Next one, U cross V is the 0 vector if and only if U and V are parallel. Okay, and that comes about from property 2. But in summary here, to test if two vectors are perpendicular, we want to know if their dot product is 0. To test if they're parallel, we want to know if U cross V, their cross product, is the 0 vector. So there's 2 different tests. Typically, we're going to be testing for perpendicular, not parallel. The last property you do not have to memorize. You've got an example in your book, and I'm not even going to talk about it. Okay, so here is a big example. We have 3 vectors, P, Q, and R in R3. We want to find the area of the triangle determined by P, Q, and R. So I have that triangle here. All right. And then we want to find a unit vector that's normal, perpendicular to the plane spanned by P, Q, and R. So for A, we want 1/2 the length of PQ cross PR. So this is a mistake. It should be PQ cross PR. Why is that? Well, if I take the length of PQ cross PR, I get the area of this whole parallelogram spanned by PQ and PR. I don't want that. I want half of that because the triangle, the area of the triangle is going to be half the area of the parallelogram. That's why you see the half there. So first I need PQ and PR. So remember the order, quit making poop. If you want PQ, you take the Q's and you subtract the P's. If you want PR, you take the R's and subtract the P's. So make sure you can verify these 2 vectors here. Now let's find their cross product. PQ cross PR is IJK, 2, -1, -1, 1, 0, -2. Okay, that is 2 minus 0 is 2. The next entry is negative. I get -4 plus 1 is -3, but it's negative, so that gives me a positive 3. And then finally, 0 plus 1 is 1. Okay, so the length of PQ cross PR is square root of 4 plus 9 plus 1, which is root 14. So the area of my triangle is 1/2 of that. Okay, part B, I want a unit vector. That means length 1. Normal, orthogonal to the plane spanned by PQ and PR. So here's PQ, here's PR. They live in this plane, okay? I want a vector orthogonal to that. So what do I want? Basically, PQ cross PR is orthogonal. So it points up this way. But I want to make it a unit vector, so I'm going to divide by its length. So here's what I want. I want PQ cross PR, and then I want to divide out by its length. PQ cross PR. I've done all the work. I found PQ cross PR. That's 2, 3, -1. And I want to divide by its length. Well, its length is root 14. So let's clean that up. That's 2 over root 14, comma, 3 over root 14, comma, -1 over root 14. Is that negative? I don't remember a negative being there. Yeah. 2, 3, +1, positive. Okay, that's my answer. Finally, we're going to talk a little bit about torque. So if you've ever fastened a bolt with a wrench, you know about torque. Typically, we're not interested in the torque vector. We're interested in its magnitude. So if this is my lever arm, PQ, I apply a force. Typically, I'm going to apply it to the end of the wrench, but if I move the force vector down here to standard position, letting P be the origin, then this is my angle theta, and the magnitude of the torque is the length of the lever arm times the length of the force times sine of the angle between the force and the lever arm. So that's going to max out when is sine its maximum? Theta is pi over 2 when you have a right angle. So theta has to be somewhere between 0 and pi. You want to max out your torque, you want to make your lever arm as long as possible, and you want to make your angle theta pi over 2. So if all the forces below have equal magnitude, which one creates the most torque? Well, here's P, here's Q. If I move the force vector over here, I see this is my angle theta. Theta is clearly greater than 90 degrees. So that's not going to work. This one works. I'm maxing out PQ, and my angle's 90 degrees. So this is a good one. Only the middle one's good. This one's no good, because if this is P and this is Q, PQ is too short. Nobody's going to hold their wrench in the middle, right? Because it doesn't, well, unless you want to apply just a little bit of torque. Maybe when you're adjusting the screw on your glasses, you might do that. But otherwise, you're not going to do that. All right, so here's some practice problems for you to fill in before you upload. And ask me any questions that you have about those, and that is the end.